So I'll wear experiments.
Okay. So, because of all of these sort of things, I believe the universe has an origin point.
Okay.
I believe that there was an occasion or a circumstance in which there was no universe.
Right.
So I don't believe the universe has always been there.
Right.
And I don't believe in infinite regression. You've probably come across this before. Therefore, there has to be a initiating cause, an uncaused cause, for example. If we do a conceptual analysis of that cause, if it's something that's already existed for eternity, it can't be mechanistic, because then we would have lots of universes popping out all over the place, even overlapping with ours. Maybe we don't see why that wouldn't be the case. It would be a non-mechanistic thing that would indicate some sort of choice to make a decision to cause the universe. So therefore, would have a will.
Right.
And therefore, and also then to make the universe, it would have to have at least an equal amount of power or matter or energy as the universe itself. Cause and effect, if we say is conserved, let's say conservation of energy. So a powerful thing that is not the universe, so isn't matter and energy, that has enough energy as the universe
the Kalam
itself.
argument.
Similar to the Kalam argument.
All right, so let me try and address that.
Sure.
First off, I don't think there's any evidence the universe had a beginning. I don't. What there is evidence for is that there was a Big Bang. But was the Big Bang really the beginning? Well, it's certainly true that there are singularity theorems proven by Penrose and Hawking, and I've worked with Penrose and Hawking, so I know a little bit about this, that say the universe had a beginning at the Big Bang. But those theorems have assumptions. One assumption has already been shown to be false, and that was shown in 1998 with the acceleration and expansion, because those singularity theorems assume gravity is always attractive. Dark energy shows us there is repulsive gravity out there. Therefore, the assumption in the Penrose-Hawking theorem we know to be false. Okay, so straight away what we used to think the Big Bang was the beginning, now we can't say that. Also, as you kind of alluded to, our current understanding of physics breaks down at the Planck time. That's true. It doesn't follow from that the universe had a beginning. Right?
No, I'm just saying
people have tried to construct what are called quantum theories of gravity, and there are many attempts at this: string theory, loop quantum gravity, Ajava gravity. What's interesting is that all of them seem to point to a pre-Big Bang universe. The universe was contracting before it was expanding. Okay, and so that tells us we are not in a position to say the universe had a beginning. So that assumption of the argument doesn't seem to be correct.
Well, so you don't believe?
No, not according to me. According to the scientists like Roger Penrose, Stephen Hawking, and other scientists.
So you don't believe the universe had a beginning?
Correct.
You believe the universe has always existed?
No, I didn't say that. It might have always existed, or it might not have. We don't know.
You don't.
There's no firm evidence that it had a beginning.
All right. So you don't know. So for someone to believe it had a beginning,
yes,
it's fine. It's their opinion. It's fine.
Yes, but it's not very compelling. What Imran said was that the science was pointing in that direction, and I'm saying the science is not pointing in that direction. The science is.
Do you believe the universe has always existed?
I don't know. Maybe it did. Maybe it didn't.
All right, but if the universe has always existed, then you'd have reason to believe that, isn't it? I think that's what you know.
No, I believe. I don't know.
I'm asking what you know.
I don't have a belief.
Well, you do.
I don't.
Well, you either accept something to be true or not.
I don't. No, but that's not the same.
It is.
Okay, it isn't. I think the universe may or may not have had a beginning.
Right.
And I don't have a belief either way. I will wait to see if strong evidence comes in favouring one statement over another, then I will believe. But right now, there isn't any firm evidence either way, because we don't have any observational evidence for anything that happens in the Planck era. Okay, so we don't know what happened, and current attempts to do quantum gravity all point to the universe existed before the Big Bang, but they don't have experimental evidence, so we don't know if they are right. But they are our best candidates at the moment. Okay, so we don't know whether the universe had a beginning. Even if it did have a beginning, causes, all our experience of causes is causes happen before their effects. Okay, so if the universe had a beginning, there was no before, and therefore we're not in a position to demand there must be a cause. Even if there was a cause.
No, that's
you've been lots of.
So sorry, Imran, go. Why don't you respond to those two?
You've sort of made lots of.
Okay, let's go with those two.
Sure,
one, science doesn't really point to a beginning, and two, even if it had a beginning, we can't be confident of.
So what I'm hearing, and I could be misrepresenting, so tell me if I am, is that we've got no idea about the beginning of the universe.
I would say we have lots of ideas, but with no firm evidence that one of them is right.
Okay.
We do have quite a lot of ideas.
So you don't know.
Okay, so so really you're coming from a place of a lack of firm knowledge. It's just these are theorems that mathematically work, but nothing actually empirical to sort of evidence.
Yes.
Okay, so that's one. So saying that we don't know, I don't think is a good argument against the our understanding that actually that everything points towards some sort of beginning, some sort of start.
But what is pointing to a beginning? I don't. At least scientifically, what?
So the fact that the universe contracts to an origin point.
Well, it contracts to a very dense point.
Yeah.
But that's not an origin point necessarily. It's only an origin point if you believe a singularity theories. But as I've said, those singularity theories, none of the people that wrote those theorems down, Penrose, Hawking, believe the assumptions of those theories anymore. They don't apply to the universe as we observe
They
it.
shouldn't bring up a singularity. Is that what you're saying?
Correct.
So atheists, just so you know, there's no singularity. Okay, carry on.
It's not that there's no singularity.
You believe there's not?
No, I don't say that. Pete, stop putting words into my mouth.
What do you say?
I don't say there's no singularity. I'm saying the theorems that say there was a singularity are not reliable. They are good pieces of mathematics. The conclusion follows from the assumptions, but the assumptions are now no longer firm. Particularly because we found this repulsive gravity. But even if you forget that assumption, there's another assumption that we believe that general relativity describes the universe in the Planck era, and that's completely unreasonable because quantum effects are bound to take a role in the Planck era.
So do you reject general relativity as well?
I don't reject it for the most part, but I do reject it as a description of a quantum era. No one in cosmology.
They're opposing each other.
Exactly.
So you reject the theory of relativity?
No, I don't know. You're trying to put words.
Once you learn something here, the man is an expert. You are not. Listen to what he's saying.
He's not saying anything. He's saying I don't know.
Okay.
You hear what you want to hear.
As usual. Stop putting words into my mouth. I don't reject general relativity. General relativity is an incredibly accurate, brilliant theory, but it is not necessarily applicable in the Planck era.
Right.
Therefore, my question to you is, I think your statement that everything's pointing to an origin point, I don't accept that.
So what I've understood is that the more that you're learning, the less that you know. That's really what I'm hearing. I'm not hearing anything more than that. And I'm saying that's an unreasonable position to be in as human beings, because we are rational and we do apply a rationale to even things that are not empirically observable. We do this all the time.
Yeah.
So for me, let's say intuitively, I think that the universe couldn't have just been around forever because of the many things that I've mentioned before. But also intuitively, it doesn't make sense to me. Okay. And when I then look at within the universe, see, there's another point that you mentioned that I've forgotten now that I'll probably come back to.
So there were 2 points.
Yeah.
One is science doesn't really point to the Big Bang being the beginning. I wouldn't agree that it's the more we know, the less we know. We've learned a lot. We've learned there was a Big Bang. We didn't know that, right? But what we now think is that the Big Bang was not necessarily the beginning. Okay, that conclusion is no longer the consensus view in cosmology today. Okay. So, and the other point was, even if there was a... Okay, go ahead. Let's deal with that. Let's deal with that.
What was the other point?
The other point was, even if there was a beginning, causality happens, things that have causes that we understand have prime moments in time. We've never seen a cause that didn't have a prime moment in time. Sure. So if there was a beginning to the universe, there wasn't a prime moment in time. So we don't really know what causality would even
we don't
look
understand
like.
it.
Sure. So what I would say to that, it was when I used my words, I was quite specific. I said there was a circumstance in which there was no universe.
Okay,
so
sure.
I tried to avoid time language because I understand what you mean.
But time is a property of the universe. So.
Sure, of the universe. Sure. But there was what I was saying. There was a circumstance in which there was no universe.
Okay.
So that would mean before time and before space. And I think that, and therefore, so whatever caused that universe, is the causal mechanism is beyond our understanding of causality as we know.
Okay.
But it originated the universe, and therefore we have what we have now.
Right.
Now, that's one concept. So I believe that the universe did have a beginning, even though all of these theories are sort of being put forward as muddying the waters until we have more firm understanding. And
can I ask, do you accept my point that the science isn't really pointing to a beginning? You do accept
sure.
that?
But my view on science is probably slightly different to yours.
Go ahead.
The underlying basis of science is that there are no non-natural causes, so it precludes any hypothesis or theories that go beyond the nature itself. So it's sort of self-limiting, in its conclusions, and that's probably, from a theistic perspective, a downfall. So, with that understanding, I know why you say what you say, because that's the limiter that's been put on you, that you have to find a natural cause. And which is why we're going to go around in circles a little bit. We're not going to get to the nub of this, because I'm positing a supernatural cause, and that doesn't fit into the science model. So we're not going to agree. That's too big a bridge to sort of gap. The other thing that I see actually is just to what we see sort of in the universe itself, sort of the organisation. I know these are sort of, you understand this. The argument for the fact that the fine tuning, for example, and I know that you have views on this as well.
Sure.
But actually, other things. For example, if you look at sort of the how frequently mutations occur to organisms or DNA to bring about evolution, because I don't deny evolution exists, that just the mechanism is the issue. If you look at that, and we look at the time span in which there would have been evolving proteins on the universe, the diversity that we see is not explainable in the time frame that we have, from my perspective. So that's one. So I think that we haven't got good explanations for the diversity of biological matter, looking at the time frame that we have for biology to have evolved so far. The other thing that we have many things that are not reducible, in my view. So consciousness, for example, it's not reducible down to any particular area of the brain, even.
I agree with that. I agree with that.
And I think these when we look at the basics.
So basically, fine-tuning, evolution, consciousness,
and and rationality is an a priori assumption. I think we can't just make that a priori assumption to then do our rationality. We have to explain those.
Let me try and address those 4 points in a short series. I mean, we can do this again. This is a great chat. Okay, first off on fine-tuning. I think fine-tuning is a very bad argument for theism. And I'll try and give you it's a long topic. We won't have time to go into too much detail. First off, we don't know that the universe actually is fine-tuned, because there are lots of papers actually disputing this, and we can't do an experiment where we change the constant of nature and see what will happen. We can't even predict from the constants. If I gave you the laws of nature and the constants, and I asked you to predict, does our universe have life in it? You would predict that it doesn't, because you would say the matter and the antimatter would annihilate, and we would live in a cold, dead, sterile universe. So you would get a false negative. So if we get a false negative for the one universe that we can observe, how confident should we be for the gazillion other universes that you cannot observe, right? Not very confident. I'm not saying fine-tuning is wrong, I'm saying we don't really know it to be true. Okay. Second off, let's suppose it is true. Okay. So this claim is that our universe is very unlikely. Yeah. So it could be. There's plenty of good non-theistic explanations for that. One, it might be that the constant nature is just necessary, that it couldn't be any different to what they are. Therefore, they are not improbable. Or it could be, if you come up with any improbability thing, it could just be you rolled the dice loads of times. So we could live in a multiverse or something like that. And the multiverse is actually a prediction of inflationary cosmology. It's not an ad hoc add-on to try and deal with fine-tuning. It comes out of inflationary cosmology, which is our best and consensus view of how galaxies form. So this looks like a better explanation, than a being that doesn't have a mind or a brain. Doesn't have a brain, a physical brain, but does have a mind. Lastly, it's a bad argument in theism. There's a very good, I recommend you read this guy. His name is Hans Halvorsen. He's a professor of philosophy of physics, but he's a theist. And he's going around saying, theists, please don't use the fine-tuning argument. It's a bad argument for theism. And his argument is this. It's a good argument for deism. If you're a deist, you should use this argument. But theism makes the claim that God is the source of all things. Right? And God must have fine-tuned the universe because he wants life. He wants a life-permitting universe. So he's fine-tuned the constants to give us life. Okay? Why is that a bad argument for theism? Because under theism, God is the source of not just life, but the probability for life. That's down to God too. Now, why would he make the probability? If you think he's a life-loving being, he wants life in the universe, he could have made the probabilities for life to be high, but he's made them low. And the analogy that Hans Halvorsen gives is, imagine you've been kidnapped by aliens, right? And they make you play Russian roulette. And you play Russian roulette, you pull the trigger, and you survive. And your hypothesis is how was it that I survived this unlikely event is that the aliens were benevolent. They wanted you to survive, so they rigged the game to make it so that you survived. Then you look at the chamber. What do you find? you find there were bullets in all of the chambers. Does that fact alone confirm the hypothesis that the aliens were benevolent? That fact alone does not confirm that. That's disconfirmation. So for theism, fine-tuning actually turns out to be a bad argument because it's predicated on the fact that there's some probability that's outside of God's control that he has to sort of compensate with his tuning. Do you see what I mean? Like if you have a radio that only a tiny dial on the radio has the signal that you want, yeah, an intelligent being could fine-tune it. But only because there's all this static on the radio. Well, why is there all the static on the radio? Why didn't you just make a radio where every bit gets a signal? You see what I mean? So it's a bad argument for theism, and particularly if you believe, as you said, this seems to be where the contradiction lies, that you're sort of doubting evolution can come out with a complexity. But no, sorry, I thought that was your protein argument.
I'm saying that.
Sorry, then I misunderstood you.
Sure. So. Okay. You've mentioned lots of things. I haven't mentioned them because this is your time to talk. So,
yeah,
but I won't go into all of that. But just sort of this, I'm going to try and go backwards because I'm going to
forget we've got to finish up soon. Yeah.
So the idea that because we're in a life-permitting universe, just to use that phrase,
sure,
that this doesn't. And if we say that this was fine-tuned by God, means that there's lots of other universes where God was unable to fine-tune it.
It's not that he was unable to; it's that he sets the probability. Maybe a different analysis. Sorry, I shouldn't. It's that, not that.
Okay. Go ahead. He sets the probability, or
sorry,
he sets the probability.
He sets the probability for life. Okay. Yeah.
So in this universe, we're making the assumption that the probability of life is low.
Yeah, that's what the fine tuning is. Right.
Sure. But I think that there is life here, and there is no reason to assume that there's not life anywhere else in the universe, because actually the probability is that it's probably quite good that there is life elsewhere.
Yeah, I agree.
So this universe is a life-permitting universe, and we don't.
Yeah.
This is a big thing to say, but we don't see any evidence for other universes.
I don't agree with that.
Sure.
Okay.
Mathematically,
I think there is some evidence. It's not compelling. It's not strong enough to say yes, I believe. I don't believe.
Sure.
But there is some evidence, and that's the evidence for inflationary cosmology.
Okay.
But go ahead.
Sure. In the model there is. Is that what you're saying?
To explain, most models of inflation predict there's a multiverse, and in fact there are certain models of inflation that have what's called a flat potential, and those models are favoured by the data, and Planck satellite can say flat potentials for inflation are favoured by the data, and those models produce a multiverse, and I think therefore there is some evidence. It's not enough to be compelling, but it is suggestive. So I say there is some evidence, but it's not enough to be sure. Yeah, I don't call myself a believer in the multiverse.
Sure. I don't know enough about physics, but as far as I know, there's no empirical evidence that there is anything.
But that is empirical evidence. You make maps of the cosmic microwave background. You then compare what properties the CMB has compared to what models of inflation, and those models of inflation that predict a multiverse are favoured by the data. That's what George Eustaphio told me. I interviewed him. He was the guy that gave the Planck data at the ESA conference. So he was the top guy on Planck. I interviewed him and I asked him this very question. Can Planck, you know what Planck is, right?
Yeah.
The Planck satellite. Yeah. I said, can Planck discriminate between inflationary models? He said, yes. I said, does it favour models that are a multiverse? He says, yes, absolutely. And he even said that's our most important finding.
Okay, so that's a whole other can of worms. Because then because if there are multiple universes everywhere, then obviously, however these are produced in whatever mechanistic way that they are produced, because according to science, it would be mechanistic.
Yeah, it's produced by inflation.
Sure. Then the fact that we haven't collided with another universe at some point already is very. If you have millions and millions of these or billions of these universes,
but they're in space that's inflating,
sure.
So they're very unlikely to collide. Yeah. It's possible we could have collided in our past, and we might see a bruise or something. But there have to be, a lot of conditions for that to happen. It has to be, the rate of inflation has to be such and such.
So just understand, sorry.
Yeah,
I'm learning.
Go ahead. Yeah, go ahead.
You said there's billions of universes in a space outside of this universe, all inflating, and yet they're not colliding. Use that as an example, because he said, why have we not collided with one, isn't it?
Yeah.
And you said they're all in space expanding. So
it's inflating. It's not just expanding. So inflation means accelerated expansion.
Inflating within what?
It's the space itself. It's not within something. Space itself is inflating.
No, but if this universe is inflating,
Yeah. No, ours isn't.
It's not.
What we mean by inflation, well, yeah, it's undergoing a very low power
Is that
inflation.
what universe inflating?
Expanding.
Well, when we say
Expanding.
inflation, okay, let's try and define our terms.
Well, let's say expanding.
Let's say no, because these things have to be explained carefully. A bit. Okay, so inflation is a period of rapid expansion, where the rate of expansion is exponential, and it doubles in size in something like 10 to the minus 37 seconds.
Wow. So there's billions of these things.
Okay, now what happens is, let me try and explain it. So what we think is in the early universe there was a period of inflation.
In this universe.
Yes.
Big Bang.
Yes, but this inflation, when it decays, so there's a patch of space
Right.
that's undergoing inflation.
Right.
And we do have evidence for this, okay? And when this patch decays, it heats up the space. It creates matter and radiation. Okay, all the matter and radiation comes from the inflating space decaying. Okay, and it decays with a half-life. Like everything radioactive decays with a half-life. So if you have a patch of radioactive substance, all right, let's just say you're eating. A good example is a cake. It's not radioactive, but this is an example I use in a radio show. My mum makes this amazing chocolate cake. It's really, really nice. Yeah. She puts the cake down on the table, and about half the cake goes straight away. We all eat it. Okay. Then when we go back for seconds, there's no cake left. We've eaten all the cake. So that's like radioactive decay. You go from carbon-14 to carbon-12. Eventually, there's no carbon-14 left. It's all carbon-12. Okay? But in inflation, things are different. Why? Because the patch that hasn't decayed is undergoing exponential expansion. Yeah? So the amount of inflating space is always increasing. It's never going down. So it's like when I went back for the cake grew. Therefore, how many pieces of cake am I going to have? An infinite number, because there's the.
I'm just trying to understand.
Yeah, that's fine.
This is a tricky question. Rob thinks I'm doing tricky stuff. I'm not.
So the no, I know you're not. I'm trying to explain it as best as I can.
So is the universe like a balloon expanding?
A bit like the balloon. It's
Right.
not exactly the same. The analogy, there's no interior. Like a balloon has an interior.
No, forget the interior. I'm not interested in the
Yes, it's a
interior.
bit more like a cake being baked.
Well, no, let me talk about the balloon. I like the balloon.
Yeah,
So
okay,
the balloon's
sure.
expanding. I forget what's inside it.
Yeah.
What's it expanding into?
We don't know is a
Right, we
short
don't know,
answer.
right.
But
But
okay, there's a couple of levels to that answer. One is it's expanding into inflating space, if inflation is true. Okay, but it doesn't, in general relativity, it doesn't need to expand into something. Space
Into
itself
itself.
has the property.
No, which is fine.
Space
But-
itself has the property that it can.
So where are
stretch.
these other universes?
They're in the inflating space.
They're inside the same universe.
Yes.
Really?
You could. The term universe and whatever sort of become difficult to understand. It's inside the inflating space. The inflating space is everything.
So this multiverse. Okay.
Yeah,
All right. So
it's all inside.
Wow.
So this inflation is ongoing
Yeah.
in other patches. If you think of the universe as everything that exists, our
How does that
little
work with-
patch.
How does that work with the singularity? Just so I understand.
Okay, so what happens is the singularity is a point in time where the space-time, curvature, density, pressure
Right.
all go to infinity.
Right.
And that is inevitable, assuming certain things. And one of the assumptions is that gravity is always attractive. But in inflation, like with dark energy, gravity is
Don't go into
repulsive.
the technical.
So now hang on, I'm trying to answer the question. So that would remove the Penrose-Hawking singularity. Now there's another singularity theorem called the Borda-Guth-Vilenkin singularity theorem, which holds even if there is repulsive gravity. Yeah. However, what I've interviewed Alan. Now, a lot of theists have made a lot of noise about this theorem, proving the universe had a beginning. And I interviewed Alan Guth about it, and he said, no, it doesn't prove that.
Right.
Okay. Okay, go on.
No, because you've completely confused me now. What's the universe according to you?
What is the universe?
Yeah.
I don't. The phrase universe can have different meanings.
What do you mean? What do you believe it means?
Well, you could define it in many ways. I mean, one way to define it is sorry.
Come this way, folks. Sorry.
So one way to define it is the observable patch that we can see, and that's about 90 billion light years
So
across.
when
or
you
something.
say that, you seem
Yeah.
to believe the universe is.
Well, you could define it that way. You could define it that way. There's different ways of defining the word universe,
Because I'll be
and
honest
things
with
can
you.
get confusing because people use these terms differently.
So here's what I'm
Yeah.
trying to understand now is,
Yeah.
according to what you're saying,
Yes.
the universe expanded, and if this multiverse is true,
Yes.
these other universes are expanding within this universe.
Yes. Yes. If you
At the
define
same time?
Yes.
At the same time?
Well, at the same time doesn't have a meaning in relativity because Yeah, in relativity,
Didn't time
simultaneously,
be- okay.
there
Wait,
is no at the same time. Time is dependent on observer. And so I actually asked Alan Guth this question. He is the inventor of this inflationary cosmology.
Didn't time begin when the universe expanded?
Not necessarily, no. Time could have... if the singularity is true, yes. But the singularity may not be true. In fact, most people don't think it is true. In which case, no, time didn't begin with the universe expanding.
Oh, it didn't? When did time begin?
Well, we don't know. It may have never begun. It may have always been
You're
there.
disrespectful. You don't really know a lot, do you?
We've learned a lot, but that opens new questions.
Every question that virtually I've heard you be asked, we don't know.
There are lots of things we know. The universe is expanding, right? We know there are other galaxies. We know there are black holes.
The universe is expanding.
Yes.
Right.
Yeah, it depends how you define expanding.
Do you think that the universe itself is quantized? It's quantized or not?
I think it's not inevitable, but it's likely. I think it's likely to be true. Well, I interviewed Roger Penrose. He has a theory now. He came up with the singularity theorems. They're called Penrose-Hawking theorems. And he now no longer thinks there is a singularity, and he doesn't even think that we need quantum gravity at the origin of the universe. And the reason he says that, he thinks the universe has been here forever.
Like this?
Not necessarily like this. It changes. It undergoes evolution.
Was it smaller than this?
Depends what you mean by small.
But you just ruled out the singularity.
Okay. I'm trying. Yeah.
If something expanded, at what point how small was it?
Yeah, well, that's a confusion of language. When we say the universe is expanding, it has a very particular meaning, and it's not necessarily the meaning that you have in everyday language.
But go back to your original point. Sorry.
Okay. Let me just answer that question about expanding. What do we mean by expanding? What we mean is the distance of distant galaxies is expanding. Okay, it doesn't mean everything is getting bigger or smaller, and the universe at the Big Bang could have been infinitely big, right? What we mean when we say the universe is getting bigger is that our observable patch of the universe is getting bigger or smaller. But the whole universe could be infinitely big, in which case it never got bigger or smaller. It's just our patch that got bigger or smaller. Does that make sense?
Well, I was under the impression that the universe is everything that exists.
It depends how you define the term universe. You can define it that way if you wish.
Well, I've realised now, maybe the problem I've had with atheists for so long is that our definitions are different.
Yes, because you can define universe in at least three different ways.
So I'm defining everything that exists, and you're defining the universe as the patch of space we can see.
I'm not defining the universe that way, but people can define it
What are you defining it as? That's what you define
I'm happy to go with... I don't care how you define it.
No, I want to know how you define it, though.
I can define it in different ways.
Well, define it in the way you believe it.
No, but I don't know. Honestly, all right. There's different ways you can define it. You can define it as the patch of space that we can see.
Is that how you define it?
No.
What do you define it as?
I don't know what the right definition is. It's a confusing word, right? Okay, I'm happy to use either definition as long as you're clear as which definition you're using. To me, that's the important thing. So in the context of what you're saying, be clear about what you mean, right? So now we know.
So you don't know what the universe is.
We do know that the universe has to be bigger than our observable
But we don't know
patch.
what we're talking about.
Now, hang on. This is one thing. You say we don't know a lot of stuff. One thing we do know is that the whole of space-time must be bigger than our observable patch, because we have made measurements of the curvature of space-time and we don't find any deviation from a flat universe. So it's either one of two things. And this must be true from the measurements that we made. It's either infinitely big or it's finitely big but way bigger than what we can see. Okay? So
that would rule out the definition that the universe is just the patch we can see, then, isn't it? Surely.
You can define words however you like.
No, but you have... Look...
I don't think it really matters what word you use as long as you know what the definition means.
If I'm defining all of it, and you're defining a piece of it, then of course it matters.
Well, if there's one...
If I'm defining all of it, multiverse doesn't make sense. Unless...
Okay.
There's these other universes that are outside of the universe.
If you define universe as everything that exists, then multiverse does not make sense. Agreed.
Of course it doesn't.
Agreed. But when you use the word multiverse, then the phrase universe isn't referring to that. People use these phrases interchangeably, and I agree they're lazy when they do so.
No, it doesn't work that way, because a multiverse is more than one universe.
Yes.
So if I believe the universe is everything that exists here, then according to this idea...
What do you mean by here? You see the confusion arises
I believe everything that exists, isn't it? As a universe.
Okay.
Everything into all the galaxies.
Okay. So all right.
So if there's more than one of those,
when we say multiverse,
I'm saying.
What we mean? Hang on.
Yeah, but that's what I'm just. Sorry, Phil. So it is Phil, isn't it?
Yes.
What do you call you, Phil?
Yes. And your name is, sorry?
Darren.
Darren.
Yeah. So this is how I've seen it. Because when you say that if I believe the universe is all time and space,
Yes.
that's the universe.
Yes.
And you're saying that a multiverse is more than one of them, then there must be another one occupying somewhere else.
Okay. When we say multiverse,
I know now. What I'm saying, this was my understanding.
Yeah,
so now,
okay, then that's wrong.
So now going
That
back,
understanding's
so
wrong, yeah.
the way I've defined universe,
Yeah.
but you don't accept the definition of a patch of space, yeah? Right? What we can see. You believe the universe is bigger than that, is that right?
yes.
Do you believe the universe is infinite?
I don't know. It might be, it might not be. I don't have a firm belief. It might be, it might not be. We don't know.
Which side are you leaning on to?
Does it matter?
I don't think it matters. I don't
Does
lean
it
either way.
matter
I
if the
don't know.
universe is infinite or finite?
It depends matter for
Does it
what.
matter?
But let me just try and clear up the issue that you raised. Okay, when we say multiverse, what I think is meant is a region of space-time from a Big Bang. And in inflationary cosmology, as it's currently understood, most models of inflation tell you that our Big Bang is not the only Big Bang, that there are many Big Bangs, and therefore they each create their own sort of what we call bubble or pocket universe.
With a bubble within a bubble.
Yes.
So
there would be an infinite number.
Can
of
bubbles
them.
occur within the bubble?
It's believed that there would be an infinite. Yes.
And none of them collided.
Like the same.
Okay, so remember that they're inside an inflating space. No, we're not saying none of them collided. In fact, it's inevitable.
They're inside an inflated space.
It's inevitable. There will be collisions. The issue is whether you
There
would
could be a
see one.
universe inside you.
Is that what you believe?
No, I don't say that.
With that patch of space.
Why can't there be a universe inside me?
Because by what we mean by inside is
Sure.
a region of
This is the way-
space-time that you're in. This would be a separate region of space-time. So the very phrase inside
Doesn't count.
doesn't necessarily have a meaning.
Oh, wow, this is deep.
Yeah.
So what you're saying now, so this patch of space we're in, the time exists or not?
There isn't a way to time. See, in relativity, there's something called a conformal time and a Lorentzian time. That these have different meanings. There are different notions of time. So, and
What you believe, mate?
well, I believe in relativity, yes.
So you- so
you
you
can't
believe- you
say
believe in
there is time, but you can't necessarily say that one bubble being born is necessarily before or after, because space and time can translate into each other in relativity in non-intuitive
Right, so this
ways.
time-
That's why I said we shouldn't use our intuition.
So this time-
relativity is not intuitive.
So this time that exists within the patch of space that we can observe,
Yes.
you're saying outside of the patch of space we can observe,
Yeah.
there's another universe
There may be.
that has its
There may
own
be another
time different to
universe.
this time.
Yeah. Yeah. They're space-like
Really?
separated.
Why do you believe that?
Well, that's even true within this universe. In this universe, there's no notion of universal simultaneity. That's true. Forget the multiverse. If multiverse turns out not to be true, it's still the case that there isn't a universal time in the universe.
Oh, there isn't?
No. The time is observer dependent. It depends how fast you're moving, depends where you are in a gravitational field. So, for example, if you're on the edge of a black hole, your time stands still. If you're going at the speed of light, your time stands still. You don't have a passage
So this
of time.
idea that the universe is 14.5 billion years old,
13.8.
yeah, you're saying this is
That's
wrong.
for us. We measure it as 13.8.
Do you believe that
billion
that's
years
true or
old.
not?
Yes. When we say universe old, that's how much time has happened since the Big Bang. But it's
That
not
time's
wrong to assume that the Big Bang was necessarily the beginning. So when we say the universe is 13.8 billion years old, that's what we mean. It's how much time has elapsed since the Big Bang. And we define the Big
Since the
Bang,
Big Bang.
and we define the Big Bang as
Isn't that the
an
creation?
evolution from a hot, dense state. And when did the hot, dense state come about? When inflation ended. So actually inflation happens before the Big Bang, not afterwards.
So you believe time existed before the Big Bang?
It may have done so, yes.
That's good to hear.
Yes.
Do you hear that, atheists?
Yes, there are a lot of atheists that make completely wrong
So that
statements.
does allow causality before the Big Bang.
It does.
fantastic.
Yes.
Oh, brilliant.
It does. It's certainly possible. The universe has always existed. Certainly, and many
But it's- so it's
what I
logical-
do,
Listen, so-
what I do is I've interviewed all the top, well, not all, many of the leading cosmologists in the field. We've just done a film with Stephen Hawking. We've worked with Roger Penrose. We've worked with Alan Guth, who invented inflationary cosmology.
You
We've-
told Stephen Hawking he's wrong.
no,
You said he was wrong.
no.
You did.
What did I say?
You said Roger Penrose and Stephen Hawking admit that they're wrong about singularity.
No. No. Well, okay. I think
Oh, they-
Hawking
he told
himself.
Stephen, yeah.
Hawking himself.
Admits singularity is not true now.
He's been saying that for about 30 years.
Oh, really?
Yeah.
He doesn't believe in singularity, Stephen Hawking.
Correct. And it's his theorem. They're called Penrose-Hawking theorems. I just made a film with him about what he thinks
I'd like to see
replaces
that.
the singularity.
I'd like to see that.
If you go on YouTube, search Skydive Film.
Okay. Skydive Film, is that you?
That's me. And we have a film series called Before the Big Bang. We've made 5 of these films so far, and there's more on the way.
You don't say I don't know a lot, do you?
In the films,
Yeah.
I don't say we don't know a lot. There are sometimes we do say that.
It's a fair
Yeah.
point because,
No, because-
I've heard everything about you, Phil. I've
Yeah.
heard Phil's the man. Phil's the man who
Okay.
studied cosmology, and it's fantastic.
I'm not an expert in
And I'm
cosmology.
not-
I've interviewed
And I'll be honest with
experts.
you, I've
Yeah.
not spoken to an atheist that says don't know just as much as you. I really don't.
Okay.
Whereas I was expecting
Yes.
the answers.
I'm sorry, we don't have.
No, but
Yeah.
here's the thing. You see, I'm not asking what. Again, most of my questions have not been what you know.
Yeah.
It's what you believe, mate.
Well, yeah, I know, but there are statements where I just don't have a firm belief. Like you asked me, is the universe infinitely big or finite? I don't
know.
have a firm belief because.
But you
I don't
also
know.
stated it doesn't matter whether it's finite or infinite.
Depends what you mean by does it matter.
Would
I
it
mean,
change anything?
Probably not.
Really?
Well, it might change something. It does change some things. Like one of the difficulties in an infinite universe is calculating probabilities. In an infinite universe, everything that's possible is guaranteed to happen.
And a finite
Yeah.
universe, does it require a cause?
There's I don't think necessarily. No.
Really?
Because to me, this is where we were having a conversation. To me, when I look at causes, I see that they're things that happen in time.
Yeah, you said time existed before
Yeah.
the Big Bang.
Yes, but if the universe is, well, it depends what you mean by finite. Do you mean finite in space or finite in time?
Finite time.
Okay, if it's finite in time, then there isn't a moment before the Big Bang.
So do you believe the universe is finite in time or not?
I don't have a belief there. It might be, it might not be.
If it is finite in time, and because you don't know,
Correct.
So possibility it's finite in time.
It's possible. It's certainly possible. I certainly
If it's
don't say
finite in time-
it couldn't be.
If it's finite in time,
Yeah.
does it require a cause?
I don't see that it does, because to me, causality, from what we understand of causality, causes happen before effects. Well, that's a good question. They're unstable, basically.
No, right. So
Okay.
what makes it unstable?
Well, the atomic structure makes it unstable. basically.
What about the atomic structure makes it unstable? No, because
Okay, I know where you're going with this. You want to go back and back and back.
No, what I'm going
Okay.
to do is very, very simple. Decay is an effect. So it
Okay,
requires a
hang
cause.
on.
Can something...
Let's choose a different example.
I
Let's choose a
would- I
different
would.
example. Okay, fine. when you look in the mirror, right?
Go on.
Look in a plane of glass, yeah, and you see your reflection in the glass, right? Some photons are going through that glass and some are bouncing off it, but their photons they're all the same. So you can ask the question, what causes?
Say that again, sorry. What does that mean?
When you look at
I look at a pane of glass.
plane of glass, you see your reflection in the glass, right? Some photons are going through the glass.
Some photons.
Yes.
Photons from where?
From wherever the light source was.
Right.
Sun, for example.
Right.
Sun, wherever the light
All
source
right,
is.
right.
Those
Some
lights.
photons are going through the glass.
Okay, so some are reflecting back on you.
What's causing the photons?
Now that's what's causing them.
sun.
That's not issue. Is not what causing the photons. The issue is what causes one photon to go